that can't take that much memory up. Oh, this stopped. Okay. Again, I mean, it's slightly higher. It's not great. It's really not great. What is this? PHP 5.6. Xdebug. No. Just to make sure. In fact, force that. PHP 5.6-v. That looks okay. It's got opcache there. Yeah, I guess if these streams were already initialized, that would make this faster. Look, I mean, if you consider what's going on here, right? The benchmarking that we're doing is we're loading in, not in this case, but in the other cases, we've been loading in actual HTML. We've been doing template parsing, we've been doing routing. This is everyday stuff. It should be fast. It's just I don't think the usual benchmarking of Hello World is this complex. For what we're doing, we need to have a way for this to work in a real application, because we can't just shove all this technical stuff. I mean, we can't just do away with all the practical stuff of making an application. I want to have something that actually works. So how do I get there? How do I do that? So this isn't that much faster. I can just delete this. I'm feeling so disheartened by this. I'll just delete all of these. Who cares? Nah, I'll delete bench. Won't delete them all. I'll delete bench. How do we get this to be faster? What if we do away with this step and see if it makes much of a difference? Stream is new memory sync. grep is a I don't know if this is the best way to describe it, or if this is what it's actually meant for, but the way that I use it is that this PHP 5.6-i is going to give us the equivalent of PHP info, but on the command line. So it's all the garbage that we would see in PHP info, right? And when you use pipe, you take the output of one thing, like echo hello, pipe into echo. Oh, that didn't work. The pipe takes the output of one thing and pushes it into other stuff, which is my very technical description of what pipe is. What we're basically doing is saying PHP 5.6, get the PHP info for this, and send its output into a function called grep. And grep uses, amongst other things, can use regular expressions or substring matches. So essentially we're saying, get the whole PHP info, and then get us a filtered list of that, because push the whole PHP info into or through grep for a search string, like opcache. So this will return all the lines from that PHP info that have opcache in them, and it's helpfully highlighted it for us. What I want to try is maybe without the container, just see if creating the memory sync directly is quicker, but then I need to alias this thing in here. Because maybe it's the container that's making this slow. All this debugging, right? It should just work, but all this debugging anyway. Okay. Start the server up at some point. Okay. Refresh bench, still works. Now go to Apache bench and try and do something with this. So this is still making a new stream on every request, and that kind of makes sense. I mean, unless we had all the templates in already created streams, and then the way that we got the templates to pass would be by running those streams through a transformer, some transformer thing that handles streams. I don't know. 5,000. I want this concurrency up above 200 before I do anything else practical in this application. Otherwise, it's a waste of time. Technically, it's not, because I'm never going to get 200 concurrent connections on any site of mine for like a personal blog or something, but you never know. It seems a waste to do a big architectural refactor when the benefit of doing it with Icicle is that it should be highly concurrent, and it's not highly concurrent. 171. What on earth? Let's up this to 500 connections a second. And sure. Oh, wait. Restart the server. Run Apache Bench. What does this do? We should be able to up that concurrency to 180. And it should perform the same results, because that's what it's telling us is being executed, right? Maybe a little bit worse for any outlying requests. Yeah, it's a pipe filter. You pipe something into grep with a search string, and it reduces the output of that thing by whatever you're searching for with grep. Grep's a big beast. It's got lots of ways that you can configure how that thing gets filtered. There's actually some cool things I'll show you as well, just because we're talking command line and I'm about to share all the things I know about command line. So that's going further than it did before. Okay, there we go. So 187 because we upped the concurrency. The concurrency actually went, the requests per second actually went up. Well, that's interesting. What happens if we up that some more? With whatever our server allows. 150 requests a second. Nope. Too many open. Or something. What? Oh, whatever, man. Whatever. Maybe we can do something interesting here. Maybe we can do a load balancer. Does that sound interesting? We don't have memcache, so it's completely impractical to try and shove the stuff in cache. But it's possible. Let's say balancer. Okay, so the things we have access to, let's put autoload in here. This is going to be fascinating if this works. Okay, so we bring the composer autoloader in, and the code that I want to use is in Icicle IO concurrent, which by the way I should probably composer update. So examples, fork. This is very interesting. Very interesting indeed. Let me get the raw of this. Bum, 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 bum. Oops. Okay. Let's put this stuff in here. Now, context. That's how we spawn forks. And all the rest of that is nonsense. This is interesting. This is interesting. Okay, let's get the dispatcher in here as well, because we want to share that across all of the forks, and maybe we'll put that outside here. Use dispatcher. Okay, and we'll create a couple of contexts here, like 4 servers. This is going to be fascinating if this works. Okay, so we've got the dispatcher there. We want to do this stuff in a separate generator function. So we'll go back into Balancer and we'll say function dispatch. And the arguments that we'll give to this are the same ones that the server gets, for reasons that will become abundantly clear. Oops, that's not great. Same arguments that the server gets in dispatch. So it's got the request and it's got the socket. It means we also need to get those things up here. So request interface. Let's put this down here for now. Up here. Okay. Okay, so we've got our instance of the dispatcher. Yes, we're going to do load balancing. That's right. I'll even bring this in here. It'll get us using multiple cores. I don't know if it'll make this any faster, but this is an interesting idea. It's an interesting idea. Okay, so we'll take the dispatcher as an argument as well. Inside this coroutine, we can just create this inside the coroutine, that's fine. Okay, so then we get our server code. Well, we want to do that. Yeah, we do actually want to do that. Server, put the stuff in here, and now we can, we can delete this stuff. Instead of yielding all this governs, we can just yield dispatch with, oh my gosh, request socket dispatcher. Now, I don't even know if this will work, but whatever. Use dispatcher there, use dispatcher here. So we're passing dispatcher down and we're listening on 8001. 8002. 8003. 8004. I'll actually move these all up one number because the load balancer will be 8001. Because reasons. I don't know what the reasons are. I don't actually know that we need the server on the outside, to be quite honest. I think, on the inside, to be quite honest, I think we can have the server on the outside. Listening on 8001, and just, well, I mean, I don't even know how to proxy to this properly. We'd have to do an HTTP client from here, wouldn't we? We'd have to do an HTTP client from here. Let me think about this for a little bit. Icicle HTTP. Let's just see how difficult this client thing is, because I may just bail at this point. Client request? I didn't consider this, actually, because I don't know an elegant way of forwarding this request. Which kind of sucks. Well, this has been an entirely fruitless exercise, and sorry about that. Let's have a look at this one more time. We're still only getting 180-ish requests a second. If we pass an array of streams, of already initialized streams in here, then we could save on the time for this for each request. But a realistic thing that we want to do is pass the stream data, like I presume this will be template data through a transformer with actual data for the request. So if it's a